Welcome back, 8th graders. It's Mrs. Thompson, and we are getting ready to start yet another video lesson. This time we're going to go to 6.2, or 6.1, example 2 is what we're going to tackle today. And I just want to go back over example 1 one more time, make sure you understand how to maneuver these negative exponents. So remember, the diameter for the Model A Ford piston could vary by at most 10 to the negative 3 inches. Simplify this expression. Anytime they say simplify, it means we really don't want any more negative exponents. And go ahead and move it if it needs to be moved and simplify it from there. Well, this one definitely needs to be moved. And we know this because it's a negative exponent. And it's negative in the numerator. So what we want to do is we want to move it to the denominator. So that's going to leave us with just the coefficient 1. So we'll leave that up top, okay? And understood 1 is always there when we move it. And then when we bump it to the bottom, the exponent becomes positive, and then we have the fraction 1 over 1,000. So that Ford piston, the diameter could budge a little bit, could expand to 1/1000th of an inch, or it could actually contract 1/1000th of an inch. So I just wanted to remind you that that's our answer. And then the sandfly example with the wingspan of 5 to the negative 3 meters. Remember, that's negative up top. So if I want to make that exponent positive, I'm going to bump it to the bottom. Now what's left up top is just an understood 1. 5 to the negative 3 becomes 5 to the positive 3. And then if you simplify 5 to the third power, which is very simply 5 times 5 times 5, you'll get 125. So it's 1/125th of a meter. And that's the simplified form of that. Okay, so I just wanted to remind you of that. Let's move on to example 2. We're just really going to delve into, moving negative exponents and simplifying zero powers, etc., and so forth. And so I just wanted to remind you, and I didn't put any zero powers on there, so I'll put a couple on there a little bit later, and we'll try these. Let's move into this first one here. We have 2 to the negative third power. Now notice that 2 to the negative third is technically, that exponent is negative in the numerator. So just like we did in example 1, to make that positive, we're going to bump it down to the denominator and then simplify 2 to the third power. That is very simply 2 times 2 times 2, which is 8. And so that's going to end up being 1/8. 2 to the negative 3. The negative exponent does not mean that the number is negative. All it means and all it indicates is that the number is super tiny. It's a fraction. It's a decimal. It's a number between 0 and 1. That is all that indicates. Okay? Now let's look at letter B. Notice the parentheses around negative 3. So what they want us to do is they want us to take the integer negative 3 and raise it to the negative 4 power. So just like we've been doing, what we're going to do is we're going to take negative 3. I'm going to leave it in its parentheses and just show you it's actually over. It's not a fraction until I put it over 1. And then if I want to make that negative 4 exponent positive, then I need to bump it down. So then I'm just going to leave 1 over negative 3 raised to the positive 4. Because I bumped it down to the denominator, negative 4 exponent becomes positive 4 exponent. Now I didn't change the sign of the negative 3. I changed the sign of the exponent. That's what's got to change when you move it. Okay, so now I need to simplify negative 3 raised to the 4th power. So remember, that's really very simply negative 3 times negative 3 times negative 3 times negative 3. It's negative 3 multiplied to itself 4 times. And so let's look at the first 2 will give you positive 9, and the second 2 give you positive 9. And 9 times 9 is positive 81. So some of you are probably wondering, well, how did we get a negative number that ended up being positive? Well, the neat thing is if it's raised to an even exponent, the negatives, every doubled or paired negative signs will cancel out, just like I showed you here. A negative times a negative is a positive. A negative times a negative is a positive. So even exponents will wipe out any sign, okay? They will. Odd exponents, not so much. You'll end up with a negative number. If you have a negative number raised to an odd exponent, your answer will always be negative, okay? So let's look at letter C. We've got, let me read it to you. This is not the same thing as what we saw up here. Let's write that down. Not the same thing. Okay, you read it differently. In letter B, that is saying take the integer -3 and raise it to the -4 power. In letter C, not the same thing. What it says is the opposite of 3 raised to the -4th power. So that negative sign right there, and I'll try and circle that, my pen is a little blobby there, but that negative sign has nothing to do with the -4 power that's there. The only way to include it is if there were parentheses around that -3, and there's not. So let me erase just a little bit here. There we go, and get my pen back up here. So I've got the opposite of 3 to the -4 power. So what you can do, because you know there aren't parentheses there, you can leave that negative sign kind of out here in no man's land and just write 3 to the -4 power, just like that. So you would literally just separate the negative sign away, put it out in front of that fraction, and then focus on this part, getting that part simplified, okay? And you can bump it up to the numerator once you've moved that 3 to the -4 power. You can actually make that negative sign or make that negative sign stay in no man's land, or bump it up to the top in the numerator if you so desire. So it's going to end up being -1/81, because 3 to the 4th power is 3 times 3 times 3 times 3, which is 81, just like above with the negatives. Except our answer is -1/81, all because there's no parentheses around that -3. That's the only difference that was made there. Okay, let's look at D. We've got 10 to the 4th power, same deal. We've got 10 to the -4. Think of it like it's over 1. And then we're just going to bump that whole thing there, that whole 10 to the -4 down bottom, and we'll have 10 to the +4. And remember, that's just a 1 with 4 zeros behind it. So it's 1/10,000. And that's the neat thing about raising 10 to any power. If it's a positive power, you just take a 1 and add however many zeros that the exponent says there are. That is all you do there. All right, E is very similar to what we did back up in B. E is the integer -2 raised to the -4 power. So I'm going to leave those parentheses around the -2. Remember, it's just kind of visually think of it as, oh, it's over 1. It's over understood 1. And I want to bump it down so that that -4 power becomes +4. And then you're going to end up with, same deal up top with the 3's, you're going to have -2 times -2 times -2 times -2. And look what happens every pair, negative times a negative, you get a +4. Same situation here, +4. And so you'll end up with a +16 down bottom. Okay, that's what happens, that even exponent will wipe out any negative signs that are in the parentheses with our number. Let's look and see what happens in letter F. Same scenario. We'll take -2, which is in parentheses, raise the -5, and we'll put it over an understood 1 so that you can visually see, oh, I need to pop that down bottom. So it'll become -2 to the +5. Okay? Now, it's the same thing as what we did above. Okay? Except there's just a 5th one. Instead of 4 of them, there's 5 of them. Okay? 1, 2, 3, 4, 5. There's -2 to the 5th power expanded out, and every pair is a +4. And then we got odd man out right there. There it is. So we have 4 times 4, which is 16, and 16 times negative 2 is negative 32. So remember what I was telling you before about raising a negative number to an odd exponent. You're going to have that extra odd man out, that the negative sign just doesn't cancel out. So you're going to end up with a negative number, and that's going to be a pretty consistent thing. Okay, well, let's look see what happens in letter G when we take the opposite of 2 to the negative 5 power. So we're going to leave that negative sign kind of out in no man's land. It's not in parentheses with the 2. So really the only thing that's being raised to the negative 5th power is that 2 and not the negative sign. The parentheses are not there, so we can't assume that. All right, so we'll leave our negative sign, and I'll put a 1 there, which means when I pop that down to the bottom, it'll become 2 to the positive 5, and then I'll have my negative sign kind of out here in no man's land, and we know that 2 to the 5th power should be 32, and so I again will get negative 1/32, just like I did in letter F, okay? So it just so happened to work out, whether I had the parentheses or I didn't, that they both ended up to be 1 over negative 32, or negative 1/32. And I think it has a lot to do with that negative odd exponent. That's what caused that situation to happen. Okay, so let me do just a couple of zero exponents with you. You go continue down your page. I'm going to erase my margins here and just give me a little bit of space. You continue down your page, and I'm going to put a couple extras here. So let's say we have negative 20 raised to the 0 power. Remember what I told you in example 1, when we're learning that lesson. Anything raised to the 0 power is always 1. Anything, that's a negative exponent. That's a fraction. That's a positive exponent. It doesn't matter. It's a decimal. It could be a variable. Anything raised to the 0 power is 1. Okay? Now, the only exception would be, and that would be because the negative sign is out in front. If you had the opposite of 5 to the 0 power, see, there's no parentheses around the negative sign and the 5. So really the only thing being raised to the 0 power is the 5. So that would be, you bring your opposite sign over, and 5 to the 0 is 1. So that would really be the only time, is if you didn't have parentheses and there would happen to be a negative sign out in front. Or you did have parentheses with a negative sign out in front, and it would be negative 1. That would be really the only time that would be true. Okay, that's it for example 2. Please review, go back and re-watch the video if you need to, if I've totally confused you. Please write down some examples you want me to show you if something's just not quite crystal clear for you. And bring your questions to class tomorrow. Thanks for viewing.